Welcome all. Today we are going to explore the second unit of grade 10 mathematics syllabus, square roots. By the end of this lesson, you will be able to reaching these learning outcomes. What are they? Approximate the square root of a number that's not a perfect square and use the division method to find square roots. Then apply square roots to solve real world problems. Okay, let's start by recalling some basics and then build up to more advanced concepts. I think you can see my screen now. Okay, as the first step, let's review. Let's go into review of squares and square roots. Okay, so first of all, let's recall what squares and square roots are. When we multiply number by itself, when we multiply number by itself, like this, we get it square. Or we can, this is equal to square of number 3. So similarly, if we multiply 5 by 5, we can get 25. It is the square of number 5. So now the square root is the opposite square. Square root is the opposite square. So as example, square root of 9. Square root of 9 is 3. Square root of 9 is 3. Square root of 25 is 5. Since the square root is the opposite of square. Okay. So how we use the square root as a symbol? We know we use this symbol. Or this symbol. You can use whether the symbol you like. It's a basic structure. It's like this. Okay? I use this because I can differentiate when I writing a long number. I can differentiate. I can separate. I can separate a number, long number, and another number. Okay. Depend on your requirement. So basically, the symbol of square root is this. So we can rewrite like this. Square root of 9 equal to 3. Since square of 3 is equal to 9, so square root of 9 is equal to 3. Square root of 25 is equal to 5. Okay, very simple. No? So we use this symbol to denote square root. Don't you have any question? If the number is in perfect square, when the number is in perfect square, what happens? What if the number isn't perfect? For example, square root of 5. Square root of 4 we can get as equal to 2 since 4 is a perfect square. But when we consider 5, it's not a perfect square. So this is where we use approximation. Okay, I think you understand now. So let's move on to our second subtopic, approximating square roots. So let's learn how to approximate the square root of a number that is not a perfect square. For example, I mentioned earlier, let's take 5. Square root of 5. What is the square root of 5? We know the square of 2 is equal to 4. And square of 3 is equal to 9. So, when we considering square root of 5 is between 2 and 3. No? 5 is more than 4 and less than 9. So, we know the square root of 5 should between 2 and 3. Okay? 2 and 3. So, but where is exactly? Let's check the square of number between 2 and 3. We know the answer must be in between 2 and 3, but how to find the exact number? Let's check the square of 2.1. Square of 2.1 equal to what? And 2.2 equal to what? And square of 2.3 equal to what? So now we consider these answers. So hurry up, find the answers. Yes? Could you find the answers? What are the square of 2.1? Is 4.41, no? 4.41. And the square of 2.2, 4.84 something. And square of 2.3, 5.29. So now let's assume which is the closer to 5. Obviously not 2.1. What is the difference between this number and 5? 4.84 and this is 5.29 is simple, na? 0.29. So, which is the closer to 5? Smaller difference is the closer to 5. So, 2.2 is the closer to square root of 5, no? So, this is called the first approach. So, we can write like this. The square root of 5 is approximate to 2.2. This is called the first approximation or approximation to the first decimal place. You can write this. This is called first approximation or first approximation to the first decimal place. Okay? I think you are completing the notes. If it is the video is playing too high or you cannot got any point, any of point, you can stop the video for a while and complete your notes. Then you can play the watch the rest. Okay? So I'm repeating again. It is called first approximation, or we can call like first approximation. Sorry, first approximation or approximation to the first decimal place. Okay. Let's try another sample. I'm moving to the next subtopic. Okay. Yes, practice approximation. So let's try another example. Right. 17. What is the square root of 70? So first write what we know. We know the square of 4 is equal to 16. No? And the square of 5 is equal to 17. 17. No. 5 is equal to what? 25. So, simply you can guess the square root of 17 is more closer to 4, no? 4. Because 16 and 17, the difference between 16 and 17 is just 1. So, let's check the number between 4 and 5, and the square root of 17 should be closer to 4. Then we take our guess like 4.1, 4.2, 4 now. Okay. What is the? Let me write like this. What is the square of 4.1 and what is the square of 4.2? Please do the calculation and take your answers. Then square of 4.1 is equal to 16.81. And square of 4.2 is equal to 17 point. Thank you. Is 17.64. Decimal, two decimal. So, which one is the closer to 17? Is it 16.81 or 17.64? We can find the difference between 16 point. Now we are going to find the difference between 16.81 and 17. And what is the difference between 17.64 and 17? So is 0.64. What's the answer? 0.19. No? 19. So, what is the closer one? No? The smaller difference is so the closer one is 16.81. That means the approximate the square root of 17 approximate for 4.1. So now it's your turn. Find the square root of 20. I will give you 1 minute. Yes, if you want more time, you can stop the video and find the answer and then play the video. The answer is 4.4 something. So, we are going to move to our next topic. Next subtopic. Okay, you can write this. You can write this note one by one. Surely I can give you this note also. Introducing the division method. Now let's learn a more precise method to find square root. Division method is a more precise method. This method works for any positive number. Our previous method is not possible for some, actually it's not user friendly now. But this method is works for any positive number, whether it is perfect square or not. So here, now we are going to find the square root of the one of big number 1764. Okay, what a big number. How to find the square root of it? Using 4 steps, you can write one by one. Okay, please write one by one. Step 1. Step 1 is separate the digits into pairs. Separate the digits into pairs. Starting from the decimal point. Okay. Step 1 is separate the digits into pairs starting from the decimal point. Step 1 is separate the digits into pairs starting from the decimal point. Step 2, find the largest number. Find the largest number. Those square. Find the largest number. Those square is less than or equal. Those square is less than or equal to the first group. First group mean our first pair. Pair or the number remaining as a first group. Okay. Step 3, you can understand more when I solving this. But prior to this, you should write this. Step 3, subtract. Subtract subtract those perfect subtract those perfect square. Subtract those perfect square from first group. Subtract those perfect square from first group and bring down the next pair. And bring down the next pair. Okay. Step 4. Double the number. Step 4 is double the number above the line. Double the number above the line. Then find the digit. Then find the digit that less than or equal obtain pair. Okay. The steps are somewhat confused, but after we solving the problems, you can perfectly fit in these four steps. You can get a summary, or you can write it your own words when after we are going after we solving this. Okay. So let's move on to the steps. First, what we do as step one, we separate the digit into pairs, starting from the decimal point. There is no any decimal point, so we separate this digit into pairs, red color, digit into pairs. This pair is first. Okay. We start the pairing from the decimal point. Okay. Then what we do? Separate the digit into pairs. Find the largest number. As step 2, we should find the largest number. Those square is less than or equal the first group. 17 is the first group. Now we should find the largest number. Those square is less than or equal to the first group. Okay, less than or equal to the 17. What is the less than one is 16, no? Less than or equal, not more than. 16 is the less than number, not equal. So what is the square root of 16? It's 4, no? Because square of 4 is 16. So what is the largest number, the less than or equal of first group of 17? The 16. Square root of 16 is 4. So as step 2, find the largest number, those squares less than or equal. Yeah. Okay. Step 3, subtract the 16. The subtract the 16 from 17 and bring down the next bracket. In simply like this. This is the our action. Repairing starting from the decimal point if there are any. So we could get two groups as 17 and 64. First we consider 17 and we find the largest square less than or equal. The first group for 17 is the 16. So the square root of 16 is 4. Write 4 and 4. 4 by 4 is 16. What is the difference between 17 and 16? 1. Then we take this group the down 64. Okay. As a step 4, double the number above the line. What is the number above the line? Is 4. Now we are going to double the number above the line. So it's 8. It what? Yeah. Then find the digit such that less than or equal. That means if we put here 2, we put the same number up there and 82 by 2. What is the answer? Is 2 by 2, 164. No? So we put 2 here and 2 there. And 82 by 2 multiplied by 82 by 2 is 164. 164. Yeah, no difference. So, what is the square root of 1764? Is equal to 42. This is the answer. I think you got this one. So, the square root of 1764 is 42. Okay. This is one homework. What is the square root of 676? Can you find this? I leave it to it up to you. Find the answer. Yes. Now we are going to move our next topic. Apply the square root to real world problems. Okay. So write this one. Please write. If the square garden, if the if a we don't know the garden. If a square garden, square garden, a garden, I think, square garden has an area of 441 square centimeters. What is the length of one side? What is the length of one side? All good? How to find this? We know how to find the area of square. Area of square is equal to length of one side square of length of one side. No? So let's assume length of one side is x. This is x. Is x. Is x. No? So we multiply x by x. Or we can simply write area is equal to square of x. So it's equal to 441 square centimeters. Now we are going to find the square root of this. We got the square root of both sides. So shall we use division method? Finding the square root. I divide to two groups starting from there. What's the largest possible less than number? 2. 2 by 2 is 4. No difference. Then the second group, 41. Double the number above line. 2. Double of 2 is 4. 4 what? 41. No? 41 by 1 is 41. So, no difference. Therefore, the answer is 21. What's the unit? Centimeters. 21 centimeters. The answer. Okay. Please write this. If you have any confusion, you can watch again the video. Like that. Okay. Shall we move to another example? Another problem? Uh, write this also. A courtyard is covered with mm, yeah, another need. Maybe I have to do for two, no? A courtyard is covered with 324 square tiles. Number of tiles, okay? Square tiles, each with an area of each with an area of 900 centimeters. 900 square centimeters, okay? 900 square centimeters. So, what is the length of one side of the courtyard? What's the length of one side of the court? Okay. So, I is courtyard is consist of tiles. Okay. This number of tiles, all are square tiles. Okay. All are square tiles. They provide this courtyard is consist with 324 tiles. And the area of one tile is 900 centimeters. So they ask to find what's the length of one side is courtyard. Let's assume it's x. So what's the x? What's the length of one side of the courtyard? How to find this? Let me explain. First, we should find the length of one tile. No? To find this, we should find the length of one tile. We know the area. We know uh, we know it's a square one. So we should find the square root of 930. So length of one tile 30 centimeters. So and there is 324 tiles in this courtyard and the shape is square. So finding how many tiles consist of one side. One side, okay? How many tiles? To find this, we should find the square root of 325. Practice division method 325 using what is the less than largest square is 1, no? Two. So second view is 24. We double number 2, 2 into 1, 22. No, eh? It's fine. 22 is 44. 2 into what? Find the number. Should be 8. So 22 by 8 is how much? The answer is 18. 18. Okay? 18. The number of tiles consists of one side is 18. 18 tiles. Now we know the length of one tile is 30. The number of tiles in one side is 18. So we can find easily what is the length of one side is 18 by 13 is equal to 540 centimeters. You can leisurely find this again. Please stop the video and find, then you can play again. Practice problems. We can find so write one by one. First one is find the square root. Find the square root of 20. Find the square root of 20 using the approximation method. Using the approximation method. We use division method here. Okay. First one is find the square root of 20 by using the approximation method. Second one, use the division method. Use the division method use the division method to find the square root of 1024. Okay. Third one, third question. A square piece of a square piece of cardboard. A square piece of cardboard has an area. A square piece of cardboard has an area 1225 square centimeters. What is the length of one side? What is the length of one side? What's the length of one side? Okay, these are the practical problems. Please write the notes and solve the problems before you are participating into the class. Okay, this is the end of today's lesson. Can you recap what we learned today? What we have learned today? Square root are the opposite of squaring number. You can also write those things. Are the summary. Okay, it's the summary. Other summarized points you should remember. Square roots are the opposite of squaring a number. And then what we learn? For numbers that aren't perfect squares, we can use approximation to find their square roots. No? And the division method is a precise way to find square roots. Then what we learn? Square roots are used in real world problems like finding the side length of a square. Like, okay, thank you very much. You did a great job today, and uh, you, I wish you all keep practicing those things, and you will master square roots in no time. Okay, thank you very much. See you again.